Well, this is going to be a video of 5.9, which is the distance formula, but we have time in this video just to finish number 15, which I didn't get to do last time, so I'm going to do that now. So this is the last problems from 5.8. And it said that y varies with the square of x. That means you have k in the numerator, k is always in the numerator, x squared, and the cube of z cubed, and inversely with the square root of w. So that's why the square root of w is in the bottom, because it's inversely. So they give us a set of numbers here, so we can find k, and then we use that k to solve for y here. So we're going to have y, which is 44.8, equals k, which we're trying to solve for, and then 16 times z cubed is going to be 8, all over the square root of 2. If we do that calculation, we'll get 44.8 is equal to 128k over root 2, and therefore we're going to get 44.8 times root 2 over 128, and that'll give us our answer of k equals 0.4949. That's not our answer, that's just the k. Once we get that 0.4949, then we reevaluate it with these numbers over here. Okay, so we're solving for y is equal to k, which is 0.4949, times x squared, which is 4, z cubed, which is 64, over square root of w, which is 4. Well, these 4's divide out, so it's going to be y is equal to just 64 times 49, and that's going to equal y equals 31.68. So that finishes 5.8, and the next one will be on 5.9. So the distance formula is really the Pythagorean theorem in disguise. I just want to show you that, and I drew these graphs just to show you. So if you take the point negative 83, 889, it's not exact, but there's a point there, and then negative 5, negative 35, negative 34 is approximately here. And we're looking for this distance. Well, what I want you to do is to visualize making a right triangle, and then think of these as two legs of a right triangle without the hypotenuse. So the distance is always the hypotenuse of a right triangle. That's the way I want you to think about it. So for number 1, you just look at the difference between the x's here, and that's going to be that's 48. Difference between the y's. You do the difference between the y's. Just do absolute value. That's going to be 55. So forget about the negatives. It's going to be 55 squared. And then the difference between the x's, that's going to be 48 squared. And you take the square root of the sum of the two squares. So it's the difference of the x's squared, the difference of the y squared. Add them together and take the square root, and that'll be 73. So 73 is the distance between these 2 points right here. Now we have 4.4, negative 3, and 3, 3. And do the same thing here. The difference, you can write it vertically. Sometimes it helps to do that. The difference of the x's is 1 squared. Forget about the up or down or plus or minus. The difference here is 6, so that's going to be the square root of 37, and that's about 6.08. That's all you have to do there. But if you want to visualize it, it'll be right here. So if you had 4, negative 3, and 3, 3, you can visualize a right triangle that looks like that. On number 3, you have 5, negative 11 there, 53, comma, negative 60 down here. So just visualize a right triangle here. We're looking for this distance right here. All right. So again, the difference in the x's, you see that's 55 again. And the difference here is 48. So we're going to get the exact same answer we got earlier, because we see we have 55 and 48 squared again. So we're going to have the same answers. So therefore, it's going to be the square root. And that's going to be, what's that going to be? That's going to be 73 again. Now, on number 4, we have 69, negative 47, and we have a approximate triangle looks like this. The difference between the x's is 20. The difference between the y's, careful, it's a negative there, so it's like 47 plus 52, which is 99. And you get the square root of a really big number, it's just under 400. So it's going to be 19.94 if you do that in your calculator. There you go. So we're having a distance between these 2 points. You have these 2 points right here, 18.3. So there's my distance I'm trying to find. Again, it's the Pythagorean theorem, right triangle. The difference between the x's there, that's going to be that's going to be 18.28 minus 1.73 squared plus 1.73 minus 3.989 squared. Look at those right there. And that'll be 19.94. Okay, so number 4, I think I put my wrong answer down there. That's 19.94. That's not. That was a mistake. It's 100 plus 400, so that one was 101. Sorry, that was an incorrect answer before. So when you put this in your calculator, you get 101. Sorry about that. Okay, so for number 5, that one's about 19.94, which makes sense because if you have this one here is about what, 16 and a half, and this one's about 12, so the answer has to be bigger than the two distances, right? So the difference between here is 18 is, what is this, 16 and a half? The answer has to be bigger than 16 and a half, a little bit bigger. Likewise, when we look at the previous problem, well, yeah, so if you have 20 and 99, so the answer has to be bigger than 99 because the hypotenuse, which is the distance to the longest side of the triangle, so it has to be bigger than 99. So that's another way to check that you have the right, your answer's in the right ballpark. And number, what's this number? Yeah, I did that one already. So number 6, you have these 2 points. At some points, some problems on my open math, they give you a grid with the hash marks, and you can figure out, you can count the spaces. So that's -3, 1, and then they give you a dot here, which I wrote down as 0, 5. Okay, so sometimes they just give you a graph, and where they have the coordinate plane with the units marked. So therefore, you can just count spaces. You can go 1, 2, 3, 4. That's 4 spaces, and this is 1, 2, 3 spaces, and do the square root of 4 squared and 3 squared, which is the square root of 25, which is 5. And that's a Pythagorean triple. 3, 4, 5. So therefore, in this case, they have a grid here in my open math, and you can count the spaces 8 here, you can count the spaces 16 here, and then you can compute that directly, and you'd have the d, the distance, the hypotenuse of the right triangle is equal to 8 squared plus 16 squared. So I know the answer has to be bigger than 16 because that's the longer leg, and we know the hypotenuse is the longest of the 3 legs. So if you do that work out, you should get 17.89 units. There you go. And then the last one deals with a map. How many inches on a map between different destinations? We have New York City and Orlando. And that's the coordinate of New York City, that's the coordinate of Orlando, and they want to know, well, what's the distance between New York City and Orlando in inches on the map? Well, distance can equal to the difference between these x's here is going to be 40. Doesn't matter if it's negative 40 or positive 40. Okay, 40 squared plus, now the difference between these two numbers, think of absolute value, 23 minus 12 is 11, so it's 11 squared. And then the distance, so the answer has to be bigger than 40 inches, right? Because the diameter is the distance, which is the hypotenuse, is the longest side there, so it's going to be 41.48 inches. And that's it for 5.9. Hope that helps.